We haven't finished the migration completely, and things keep changing in Cloudland. So this stock has changed quite a bit in the past 3 months. Okay, not too much, but quite a bit of it has changed simply because the finance has changed. So our starting point was we had a bunch of legacy hardware running in a DC. It was getting to be at a point in a replacement cycle where we could just junk half of it or more. Lots of profitable legacy software, which is important. We were running on a mix of really old bare metal, and we had a bunch of OpenStack cloud with a bunch of self-service tools around it. We had working continuous integration and continuous deployment, one of those things that apparently a lot of enterprises are now getting around to. We had working config management, which is common. And we had a very small infrastructure team. It's about 7 people. So we can move really fast when we need to. Software is, for us, not an essential, is an essential business component, but it's not our prime business. We are really marketing and publishing. And we have developers on call for production issues. That's been a thing for a few years. If you can meet these starting conditions, you should probably do that. The old hardware may or may not be important. If you're moving to public cloud, then it makes complete sense to just take a look at the economics first, because you have to start thinking in terms of exactly how many euros is this operation going to cost me. You leave a VM, if you're running a VM and it's running on hardware, well, it costs you a few cents of electricity. But if you're doing that in the cloud, it costs you a few euros instead. Cloud considerations, for us, we were kind of on the margin with a few hundred machines. So we could have said no to the public cloud, but we kind of also need scaling issues. For us, the really bad part is if you have a successful game and then you suddenly realize you can't scale the backend up fast enough. And there is no sense in buying a backend, in buying lots of hardware for things that may or may not scale, or may not need scaling at all. If you're unlucky, your bad results are like the Pokemon Go game, where the big problem is scaling. We have variability in demand. If your demand is consistent, pretty much keep it in-house. We have a very high variability in demand. And, well, legal issues, so you cannot just go around randomly with Brexit and GDPR. You cannot say, oh, I can put my machines in the US or geographically dispersed. They must stay within specific geographies. And your software must be observable. The modern buzzword is observability. Traditionally, this would be something that you would put into your own code as logging statements, metrics emission, whatever. But a lot of commercial software simply didn't have this back in the past, so your ability to monitor it was very limited. If your software has good observability, you can actually debug issues. Cloud kind of restricts you on what you can see, because it is simply very hard or impossible to just get metrics from lower level systems. Vendor choices, we were already using Docker. That helped. We are already doing a microservice migration from well before. Not essential, but it helps establish a mindset that we needed. We were doing Mesos, so Kubernetes was easy, which is kind of why we chose Google's cloud. It was just a teeny-weeny bit better and quite a bit cheaper. The cheapest would still have been running our own hardware. Savings for a cloud move mostly come from not needing a dedicated hardware operations group, or at least operations group. And you can avoid a bunch of high availability requirements because the tooling in the cloud lets you automatically respawn VMs if they crash. So you don't have to have multiple pieces of hardware to do the same thing. You can just say, OK, just make sure this thing stays up. I want at least 5 units of this running all the time, and software will do that for you. So we started off with a little technical research phase that started around last year's config management camp, where we looked at various options, and that lasted for about 6 months, quite a bit of research. Well, not too much. It was mostly infrastructure management and what we could do to automate it, because we already had automation, and we were simply not willing to live with, oh, look, I can run a command line utility to solve this problem. We totally dislike that sort of attitude there at work. It's more like, I don't care, just make it work. And if you can do that, then that happens for us. Okay, so we did a bunch of manual work first. And then, so we got some, just to learn the terminology, concepts, and to discover various limitations of tools. Most tools have limitations of various sorts. When we started, Terraform was not as nice as it is now. It's improved a lot in the past 6 months. Load balancing, IPv6, some DNS issues occasionally. So all those things, usually quite a lot of them. Automation tools, we started by simply writing shell scripts. Your gcloud and gsutil. AWS has their own AWS command line utility. I think Azure has something similar. We had Ansible experience, so we played a bit with Ansible, but back in the days, it was very limited what we could do, and for a bunch of stuff, we would just have been going down to saying, run this gcloud command. Not very nice. We could have used Puppet, but it had barely gotten to the point where we could stand up infrastructure. So at some point, I wrote a basic proof of concept that would spawn a VM, and the way that worked was you would take a machine, it would spawn up a local vagrant box, and then a local Puppet applied that would spawn up a machine in the clouds. Not so nice. Terraform was the best of the lot. It has improved a lot since this slide set was made. Back then, it would be like, OK, let's gamble if it works. Now we can do a little bit more. It's gone from Puppet in 2007 to maybe Puppet in 2009 equivalent. If you used Puppet in those days, you would remember how big a difference that it was then. Configuration management, you need something. Doesn't matter what. If you're running VMs, you pretty much want config management. Because A, you want it for all the regular reasons, plus B, if you're running groups of them, what Google called managed resources, or whatever AWS calls it, the machines will automatically spawn up, and then you don't want a machine that's spawned up and going, oh, but I don't have my configuration. You need a bunch of automation in there. If it's a web service, put it in a container, be done with it. You don't necessarily need a full-fledged VM for it. Do the 12-factor auth style, 12-factor style stuff, and you're good. You need configuration management for anything that's not in a container. So your databases that you plan to run manually, other legacy applications, and that sort of stuff. Puppet was our choice of tool because we were using it, but again, use something. Nobody cares what particular tool you use. There isn't one best tool yet. And given that we are 10 years down that, 10, 15 years down that line, I don't think there's going to be a best tool. The one you have is pretty much the best one. Inventory, there's still no good, nice CMDB here, which we can use to lead our provisioning systems. The homegrown Openstack system has a CMDB where we can ideally say, add an entry here, and then the rest of the software makes it so. That's not quite where we are in the cloud yet. So we are currently generating an inventory by using the various tags and the Google API. AWS, apparently, you are expected to do something similar. And well, it's a pain, but it's not too hard to generate this information. So when we started actual work, this was somewhere around last September. One meeting with 3 people and 30 minutes, nobody else who got involved. And we decided on goals. It was complete automation, custom tooling around all the around the application bits. And we decided that this was a particular legacy application that we would move and say, well, that would be the end of the proof of concept. But now we are doing production stuff in the cloud. That particular application hasn't moved. But hey, the proof of concept was done for some value of. And it took us about 3 months of full-time effort to say this is from, we have nothing to, this is where we can be at, to say, okay, we have proof of concept, this is how things will work, this is how, and this is things what will definitely not work for us for various reasons. Did not need a lot of time to do documentation. I think In those 3 months, each of those 3 people involved was on vacation for 2 or 3 weeks in between. Terraform has excellent documentation once you get your head around it. It documents all the individual bits very well, but there are still no big picture pieces of documentation that say, this is a complete infrastructure bit, this is how you do things. Getting your first bits and pieces is pretty hard, simply because it says, oh, this is this piece, this is this piece, this is this piece. How you put it together doesn't exist. I was reading the same complaint about Amazon yesterday, so that hasn't really changed anywhere. And then, of course, we had Puppet, so we just threw away most of our old Puppet code. Instead of keeping it running, we just created a whole new repo and went, whoop, new Puppet version, let's clean up. We also junked a large part of the module approach. What we are doing is have a base module that installs packages and ensures that some services should be running. And then all the actual module for that config is implement the config. So that removes a bunch of complexity from the standard Puppet Forge style module. It's not a good way to publish stuff, but I think it reduces the size of our code base by half or more than that. So simplicity. What we did for networking was we decided these were some subnets we were going to use, and then all the network bits go into one project, and then everything else sits on top. So everything, staging, every environment corresponds to one project for us, whether it's dev, staging, production, doesn't matter. We just go with, this is it, and it's going to run in this particular network, all of which will nicely be provisioned by Terraform, at least the network management bits. Until last week, it was not possible for Google to run Kubernetes clusters that way, to manage the network, so we just defined them there. But now you can manage it. So other projects just use instance groups. Again, this grew out of what we were doing. We first started by hard coding host entries into stuff. And then we went, well, this looks very similar. So I wrote a makefile target that could generate things. And then we realized we could just create resources for that. But we still had issues with storage. And then we added some more stuff and keeps growing. Plan for things to evolve. So our code base is currently a very complex mix of, we have hard-coded things, slight variables, and then here's this fully dynamic singing, dancing template, and we go, well, new stuff should use this, older stuff can keep using the old stuff. We use Terraform to provide roles and cluster and a few other variables to Puppet, and then Puppet can basically pull those in via facts. And we can then just say, well, this machine has this role, so provision it that way. Instead of hard coding stuff onto a VM or default images, we started with a simple backend. It's the easiest way to go forward. It is entirely known to be non-performant at scale for humans. So if you have, with 3 people, it was kind of acceptable, where we could just say, oh, I'm going to work on this, I'm going to make a Terraform run, nobody touch the thing, please. But if you were doing more, if with 6 people and a couple of people working from home, good luck. Proof of concept, very useful. And then that got refactored. Charity Majors wrote a pretty good thing for Amazon about why you want a Terraform state file. We just store this in a remote state bucket and run with it. Oh yes, now the dragons. So that was the nice bits. Stuff that sucked. Documentation, Google Cloud documentation, it lags behind the software. Good luck finding out what is currently correct, because there is Google searches are pretty worthless here sometimes, simply because you have 3-month-old information that is no longer valid. As I said, this talk has evolved, and I have that disclaimer at the start. So if you can find recent documentation, it's fine. Otherwise, good luck. It's inconsistent in itself. And, well, same thing for Amazon, same thing for Azure. The API is, well, we had a few bitching sessions about this. You create a hard disk, and you say, well, I want this disk to be permanent storage. I want this other thing to be and then I have this machine that I should attach it to. Do I attach it by a name, or do I use a URL? It's a 50-50 coin toss for what you will need to use for various resources. It could be the name, it could be reference. Well, good luck. Some kind of ID, but what is the ID? Not consistent. Again, stuff still needs actual examples. API documentation is kind of like Java doc. Yep, it uses all these things. What's an actual code example? Well, some things have it now, but otherwise, good luck. Stateful data, there is no good answer for high availability. This bit really, really sucked. We had decided that we would be using Cloud SQL to replace our MySQL instances. And then it turned out that we got bitten by some very nasty features. Google offers a very nice thing for failover, except their definition of failover is, well, if the entire zone goes down, we will have failover. But if the machine is down for maintenance, and you can say, okay, it can go down for maintenance during these hours, and well, if your maintenance takes an hour and the machine goes down, there's no failover. So you're suddenly going, my database master is dead and I can't bring it up because it's under maintenance. I can't do a failover because it's not officially fully dead. It's under maintenance. Service impacting. Well, it's officially documented now, so that's the way. If you're doing Cloud SQL, that's a risk. Google does offer multiple options for storage. We use a bunch of them. We use a bunch of big data stuff for analytics and things, but again, a lot of code had to be rewritten to use that. The reliability is a trade-off. So most of our business analytics stuff got rewritten, depending on your company management and how much effort they want to put into that. You may not want to do that. It does involve code changes. So if you want really highly available stuff, you can use Spanner, but well, you're rewriting your entire application to use Spanner, not just the whole, let me change the database driver and make some minor adjustments to SQL. Well, there's no SQL suddenly for a bit. So as I said, Cloud SQL needs a whole zone to go down. If you want to use other backends infrastructures that are not SQL, well, Redis or something, again, there's no default official support, so you're going to be running your own. And you'll probably want to run your own database systems at some point. It's a bit higher risk than I like, running a random VMs on a random third-party vendor. But hey, IPv6 is a slightly bigger problem for us, but Google, not for Google. They are very happy to say, oh, if you have got IPv6 clients, they can connect to us on load balancers, which wasn't the case a few months ago, when we actually had to route IPv6 to Amsterdam and then make IPv4 callouts into Google Cloud. Of course, for us, being able to work in an IPv6 only environment is essential for commercial reasons. Compute is, when I say very limited, I mean now it supports load balancers, and that's about it, really. Everything else, good luck. If you're doing Internet of Things stuff, if you're working in the third world, if you're working in a place that, if you expect a user base in, say, Belgium or in India, with IPv6 is pretty good, you can pretty much rule out being able to make callouts from the cloud there. Amazon is definitely better at this there. But hey, secrets, passwords and stuff, if you have containers, Google now supports encrypted secrets. They didn't have this for quite a bit of time. HashiCorp's Vault is kind of nice, but it is not plug and play. I can't say replace this config file entry with a call to Vault transparently, so if you're rewriting applications to use it, yes. If you want to do it, yes, it's excellent, but sometimes you just can't because you've got too much legacy. Anything that works with your config management is nice. We tried the Hiera Vault backend, but it was kind of slow for us. I looked at it yesterday, and they had some filters which would probably make it faster. So again, maybe different. But you still have to worry about managing your master encryption keys and making sure that you can restore stuff from backup. and protecting those backups. So when I say terrible, I think it went, Puppet runs went from a few seconds or couple of minutes to 30 odd minutes-ish. Load balancing, the load balancers are very limited. I mean, if you worked with enterprise-y hardware stuff, then you have a lot of options there. And you say, well, I have time and I have got all these abilities to do things in the load balancer and send some traffic here and some traffic there. Google is like, nope, you got IP. That's it. And if you need to make, if you think you're running out of resources, please use our container platforms or Kubernetes or something to make things scale, instead of worrying about how to route traffic differently based on load or whatever. So we ended up simply replacing it with an IP-based load balancer and Nginx proxies. You may want to use other load balancing tools. We just needed web services, so it was fine. And then we had to discover some interesting bugs in code, which were especially for things that were tracking geolocation. Suddenly all our users were coming from a single country. We are a 24/7 business with users all over the world. So if you suddenly say, all my users are now coming from the UK, not very good. So we had to certainly worry about that particular bit and then fix that. It's a configuration fix, but it still needed debugging. It took 4 or 5 days to realize that this was happening. Monitoring was fine. Stackdriver looked promising, still looks promising for log management. It does not deal with metrics, so you're going to have to run your own management metrics stack. So Graphite, InfluxDB, whatever equivalents for point-in-time metrics. Stackdriver is also absolutely lousy to search on. Well, their JavaScript UI is a nightmare. But hey, it might improve. It had quite a few retention limitations, which we still haven't worked around, but GDPR makes that slightly more interesting for us, because we suddenly went from, oh, we keep these logs for a few years to, well, we can now only keep them for a few weeks. And new pricing can make it cheaper to run than running your own ELK stack. Some people don't like running ELK for whatever reasons. I don't mind it. But if you're running a few gigs of logging, just go Stackdriver or whatever log management solution. Keep in mind that most of your cloud move is suddenly going to have you thinking from, I do this with hardware, to how much is this going to cost me to run? It's a completely different mindset. It is a good replacement for the ELK stack, but it is not quite there for actual analytics or monitoring, and you have to run your own time series database anyway. So we are still running Graphite, we are still running Grafana on top, and we have a bunch of alerts based out of that. Stackdriver does alerting, but we really don't do it from there at all. Legacy code, plan on migrating it wholesale. Even if you're planning to say, I need to replace this application and we are going to do the hip new microservices thing, rewrites will take longer than you planned for. And your planned migrations will still take longer than expected. So when I wrote this thing in January for linux.conf.au, it was still, well, we'll probably be done by March or maybe mid-April. It's June and we still aren't done. We are still stuck on the same old legacy applications, because they have environmental assumptions like, oh, this is what domains will be like. We are going to have random hard-coded domain names in there. We are going to have random hard-coded host names in there. And you don't think about this as ever being a problem until it needs to move, and it's like, no, wait. Why is it even expecting that particular call to be on that host name? Oh, look, they want it to be secure. So they said, well, calls must come to this host name or we are going to ignore it. Except, well, we can't use that host name there because it's completely invalid. Oh, good luck. So lots and lots of rewrites. GDPR also had a fairly significant impact on this migration bit. If you're just moving your environment lock, stock, and barrel over, it's not going to help you. The environment with different assumptions on latency and reliability will kill your application. And I can promise you it's not fun. Those things go down more often than we like. But well, we are expect things to go down there for this. If you are doing it on your own, and management expects you can just take stuff and plonk it there and it will work, it's not going to help you. The biggest change is literally the mindset. Again, I'm going to keep emphasizing that bit. Spectre was fine for us. So on our hardware, we didn't care too much because we are somewhat over-provisioned. So actual impact was minimal. But in the cloud, we realized that the Spectre security stuff just literally doubled our runtime for anything that's data intensive. So your database applications will have an impact, and you're paying based on CPU cycles and runtime hours, so that's a fairly significant impact again. Cloud migration is a business decision, and well, it's going to be a fun one, possibly. You'll probably decide if you're a middle to large enterprise that it's not worth doing, simply because the economics don't work out. If you're running more than for about a few hundred machines, it's simply just too expensive to do that. And you'll have to keep monitoring your costs closely. We have official alert. We actually have alerts based on when things start to run out, and we have fairly low budgets. You'll discover a number of ways in which money is wasted in the cloud. Sometimes it's just that you have over-provisioned the machine, slightly expecting that this is going to be what load the machine is going to take. And then it turns out, well, no, that's not going to happen. And then you realize it's costed you a few €1,000 suddenly. Well, I did that. I provisioned a machine for full load, and then we realized we weren't anywhere close to that. Or we had debug logging, which is why we were going to run ELK. And then we realized that, well, if you turn off debug logging and keep it to a sane level, reduces like 90% of your log volume. Internally, we didn't care because, well, it's just disk storage, and we have a lot of it. So who cares, right? Storage is cheap. In the cloud, suddenly that gets expensive. So our stack driver expenses would have been somewhere in the few €1,000 a month range. It dropped to about a few hundred, couple of hundred or so. Essentially, the point at which you go, well, running our own infrastructure is going to cost us more in man hours and in discussion about running it than just using stack driver. Outsourcing your L1 operations team to people who don't care, same problem as was 15 years ago. The support still sucks. Well, it sucks less if you pay more, but it still sucks, and you still can't go just say, I would like to have ILO access. Does not work. Their priorities are not your priorities, and sometimes you're like, this particular thing is broken. Well, it's working as designed. We had this problem with the Cloud SQL thing, and it's popped up a few other times again when the vendor's priorities are not yours. Choosing which provider you want to go with, it's pretty small differences still at this point. You don't care too much about what the big differences are because effectively they give you the same thing. If you're running your own databases and your own other thing, well, and your applications are moving lock, stock, and barrel, doesn't matter. Kubernetes and containers are now supported equally everywhere, so it shouldn't matter too much again. So if you're going to run with really small differences, you basically go with, well, what's the price? And what's the best option for supporting? Tooling is still raw, as I mentioned. We are still discovering operational design patterns. There are no published best practices out there except for very small startups. But hey, we are getting there, another 5 years or so before we have actual useful information. And of course, migrating is going to require a whole change in process and mindset, especially if you're a large ITIL shop that thinks, well, we are now agile because we can do a release every 15 days. No, that's not going to work out for you. Everybody, including developers, is going to have to be thinking in terms of dollars, cents, euros, saying, oh, is this algorithm more efficient? You could just say, well, hardware is cheap. Suddenly in the cloud, it's not because you're now paying per cycle. Can you reduce your data usage? Can you reduce CPU cycles? Can you deploy faster? Can you make changes more often? How good is your CI? I mean, I can literally actually merge a change right now into production, and if it will work, assuming somebody's approved my push request, somebody's approved my pull request. But I can do this at 6 p.m. I could do this on 6 p.m. on a Friday, and we would go, well, business as usual. If you can't think of being able to do a rollout at 6 p.m. on Friday evenings as business as usual, well, there's a whole bunch of cultural changes that you need to get through first for cloud migrations to work. Because if you aren't going to be in that mindset, your migration is going to fail. You cannot just say, this is a new data center vendor. This is literally, I'm going to be running stuff on very unstable hardware. And we need to be able to do very frequent deployments, lots of changes, stuff that is recommended for most startups. Yes, but now you need to do this at a really big scale. And usually talking to people who aren't used to thinking of saying, well, if it goes wrong, it goes wrong. We don't need to have 2 machines doing high availability because it will automatically respawn in 5 minutes. So, questions? Anyone?
Questions?
Nope.
Thanks for your insights. Do you have some numbers for us concerning about the sizing of the landscape or the number of heads in your teams?
So let's see. We have a team of developers for a native application game backends, basically. So that would be about 10 odd people, another 10 odd developers for our web portals and stuff, and 7 people in operations. That includes 2 DBAs, 1 hardware person, and 4 generic engineering types. But we basically are a team that can and will do everything else as needed. So even if databases are my primary responsibility, I will also do network setups and random other things as required. We all have specialities rather than full-on teams. But that's kind of what we are looking at. If you're looking at hardware, we have about 50 racks worth of hardware because legacy issues and stuff. But still, and we use most of it. We do quite a lot of analytics. So we had a whole bunch of Hadoop machines and other analytic hardware, which we wanted to replace anyway. So if you're looking at, we're looking at about, say, 1,000 odd machines total, or 700-800 machines roughly, say, in production. So that should give you a rough idea of what we are looking at.
So you will run a mixture of GCE and Kubernetes? Or do you
GKE and Kubernetes? No, it's all Kubernetes at this point.
So you try to move every application to Kubernetes?
Pretty much. The idea is that we have a bunch of things that we can reasonably split up into microservices. So that's what we are going to do with it, and then that goes into Kubernetes because that's what other things are doing. We have a couple of GKE things, but that's mostly support applications that are convenient because for the way of automation of our provisioning and other things, but not really. Anybody else?
Yep.
I have a question regarding vendor login. So perhaps you can use some tools like Terraform to abstract it, that you use like AWS or Azure. Is Kubernetes a way where you would like to create another abstraction that you can move your Kubernetes away from let's say, Google to Amazon? Or is it in any way a thing where you're discussing in the proof of concept?
No, not really. When we did the proof of concept, it was still all Mesos. The Kubernetes thing is entirely developer-driven. It's not operations-driven at all.
Okay.
If the developers think that the best way they can do stuff is via Kubernetes, then they get to choose their tools. We don't restrict people very much on what they can do. So we have had at least one person who required us to use MongoDB. I believe some people may have heard my very strong opinions on the topic.
I've heard it.
But yes, so if you need MongoDB, you get Mongo. If you want Redis, you get Redis. If you want MySQL, if you want Postgres, it doesn't really matter.
And from a vendor login perspective, so is it a thing that they say, okay, this service is now relying on Google, and if we're not happy with them anymore, that nowadays I see that more and more people build the applications around that specific cloud stack?
So for the analytics part, it's very much built around it because that was a risk we decided to take as a business risk. But if we wanted to run our own, we could just move back. It would require recoding the part of the BI stack at this point, but I mean, it would require us to do way more than just recode the BI stack again. The business intelligence bits are very much dependent on Google's infrastructure, but the compute bits of it are not. We can move those to Amazon. If you say we need to be in Amazon on next Monday, doable. If you say tomorrow, a bit harder. Because we simply would need to replace a bunch of the Terraform code, and none of us has enough AWS experience to say, well, this is how we can do, this is how things should be done. Most of the infrastructure bits are abstracted away, but at some point, if you're doing cloud stuff, you have to accept that there will be a bunch of vendor lock-in. Simply because every tool, every vendor has their own little bits and pieces that will hook into your applications, APIs, whatever, and it becomes, okay, this is what you're doing. If you want to have no vendor lock-in, just run your own hardware.
Are there some questions left in the room? No?
No?
Okay.
All right.
Thank you,
Thank you,
Devdas, for being here.
Thank you.